In this video, we're going to look at interval notation. We want to be able to read and write inequalities using interval notation, be able to convert between the number line interval notation and the inequality form, and be able to solve inequalities and write their solution in interval notation. So just a first quick review of interval notation. Most of you should have seen this in Algebra 1. So interval notation is just a method of showing a range of numbers. Most of you are probably used to on the number line using closed circles and open circles. We're going to change that to include square brackets and parentheses. We're going to replace closed circles with square brackets, and we're going to replace open circles with parentheses. So you can see some examples here of an inequality, which is where x is between a and b, including a and b. So in your previous notation, you would have had like a closed circle on a over to a closed circle on b. Now we're just doing a square bracket on a and b and then shading in between those. So our interval notation here is simply a comma b. The a and b would be in numeric order, and then the square brackets on both of them to show that we're including them. This next example is a is between a and b, but we're not including them. So again, on our old notation, we would have had open circles on a and b. So now we are going to have parentheses instead. So here we have a comma b with parentheses, and remember the parentheses mean that we're not including them. So you can see some different examples here of ways that we can write the inequalities that we're used to in interval notation. A little bit of terminology to be familiar with when they talk about a bounded interval. So both endpoints are numeric values. An unbounded interval is where at least one endpoint is infinity or negative infinity. A closed interval means that both endpoints are included unless one of them is plus or minus infinity. An open interval refers to an interval where both endpoints are not included, so parentheses on both endpoints. The unbounded intervals here are giving you the examples where at least one of the endpoints is infinity. So remember, negative infinity is always on the left-hand side and positive infinity is on the right-hand side. So looking at a couple examples here, just translating between the inequality notation, the number line notation, and the interval notation. So what we want to remember here is that no longer are we going to use the open and closed circles on the number line. We're going to use the parentheses and square brackets. So this is x is less than or equal to 3, so we're going to include the 3, so square bracket on the 3, and then less than, so we're going to go to the left. In interval notation, that's going to be negative infinity to negative 3. We're including the negative 3, so the square bracket. On the second one, we have an interval that starts at negative 2 and goes to positive infinity. So in interval notation, we're going to go negative 2, positive infinity. Whenever we have infinity or negative infinity in an interval notation, it always gets a parenthesis. To write this as an inequality, we're going to say x is greater than or equal to negative 2. My third example, I have the interval notation, so I have negative 4 to 1. So on my number line, we're going to do a negative 4 square bracket because it's included here, and then the 1 is going to get a parenthesis, and then we're going to shade in between. So the nice thing with the interval notation is that matches up exactly with the number line and just the space in between. Since this is a bounded interval, we're going to have to write a compound inequality. So negative 4 less than or equal to, because we're including the 4, and then our variable x, and then less than 1. Remember, when you write a compound inequality, always smaller number on the left, larger number on the right, and then your signs are always less than in between. In the next example, we have the number line, so we can go straight to the interval notation. So I'm going from negative 6 to 5. And I have parentheses on both of those. Again, this is a bounded interval, so when I write the inequality, it's going to be a compound inequality. So negative 6 less than x less than 5. No or equal to is there because there's no square brackets on the number line. As we continue here, the next one we have 0 to 7. Both of them have or equal to's on them, so we're going to include both of those. So we're going to start at 0 and go over to 7. So in interval notation, we have a left bound of 0, a right bound of 7. We're including both of those, so square brackets. Next, we have negative infinity to 2. So from the left, we're going to come until we get to positive 2. And then there's a square bracket on the positive 2, so we're going to include it. In interval notation, we have negative infinity to 2. So as an inequality, we're going to have x is less than or equal to negative 2. Our final example here has a new symbol in it. So remember, this is your union symbol, and it means or. So here we're going to have two pieces of this inequality. So we're going to have negative infinity to negative 4. Include the negative 4, so we're going to do the square bracket there. And then from 0 to infinity, so from 0 to positive infinity. And then we're not including the 0, so parenthesis on the 0. In order to write that in inequality notation, we have to write two separate inequalities and put the word or in between them. So x is less than or equal to negative 4, or x is greater than 0. Here's a couple special sort of interval notation inequalities that you will encounter frequently as we continue and look at properties of functions. So all real numbers would be everything from negative infinity to positive infinity. All real numbers except 0. So on a number line, we're saying we want to include everything except 0. So we want to include everything to the left of 0 and everything to the right of 0, but not 0. So in interval notation, we would say negative infinity to 0, parenthesis on the 0, and then union 0 to positive infinity. If we want to say all positive numbers, we're going to say all the numbers greater than 0. Remember, 0 is considered a neutral number, so it's neither positive nor negative. So we're not going to include the 0, but we're going to include everything to the right of it. So in interval notation, it would be 0 to positive infinity and parenthesis on the 0. All non-positive numbers would be all of the negative numbers and 0. So we're going to include the 0. So this is negative infinity to 0 with the square bracket on the 0. All negative numbers are going to include everything here to the left, and then remember not including 0 because 0 is neither positive nor negative. So negative infinity to 0. And then all non-negative numbers would be all the positive numbers and also including 0. So here we would do 0 to infinity, include the 0. Finally, a couple examples where we're actually doing some solving of an inequality, and we're going to put the answer in the interval notation and graph it on the number line using the interval notation as well. So if we just do a little bit of algebra here, we're going to distribute, and then we're going to combine our terms together. So this will give me negative 2x. Sorry, I forgot that we're equal to there. Negative 2x is less than or equal to 7. Then remember, when we divide by a negative, x is greater than or equal to negative 7/2. Let's graph that on the number line. Here's 0, negative 7/2 would be over here somewhere. And then we're going to say x is greater than negative 7/2, so we're going to go to this direction to the right, and then we're going to include the negative 7/2, so we're going to put the square bracket on there. So when I write this into its interval notation, we're going to start at negative 7/2 and go to positive infinity, include the negative 7/2, so square bracket. In example B, we have a lot of fractions here, so I'm going to multiply through by a common denominator. In this case, that common denominator is 12, so I'm going to multiply everything here by 12. So we're going to end up with 4x plus 6 less than or equal to 3x plus 4. Again, combining my like terms, we're going to get x is less than or equal to negative 2. So again, if we graph this on the number line, when you make a number line, if you can just put 0 on the number line and then any other number that you need on it on the appropriate side of 0, I don't care if it is incremented perfectly. So here we're going to do less than or equal to negative 2, so I'm going to go to the left here and then include the negative 2. And then writing this into the interval notation, we're going to go negative infinity to negative 2. Remember, always parenthesis on the negative infinity, square bracket on the negative 2 because we're including it. On the last example, we have a compound inequality, so we're going to do everything to all three areas of this inequality. So first, multiplying by the denominator of 3, we're going to get negative 9. We're going to get negative 9 is less than 2x plus 5, which is less than or equal to 15. Subtract 5 from all three sections, and then dividing everything by 2, we're going to get negative 7 is less than x, which is less than or equal to 5. So I'm going to put 0, negative 7, and 5 on my number line. And then we want everything in between negative 7 and 5. Don't include the -7, so parenthesis there, include the 5, so square bracket there, writing that into interval notation, -7 to 5, parenthesis on the -7, square bracket on the 5. So hopefully that helps with an understanding of interval notation.